I'm Tong Spencer from Group 49.
Hello everyone, I'm Po Hei from Gp49.
We are going to present our final project on principle of operation management on Tesla. For introduction, Tesla was founded in 2003, and it aimed to show the potential of electrical vehicle and show that electrical vehicle is not a compromise. Since 2015, it released 4 vehicles, which is the Model X, Model Y, Model 3, and Model S. With the Shanghai Gigafactory success, it's become the highest value automobile manufacturer in 2018. I would like to talk about the EV trends. With growing concern of the climate changes, a lot of countries abandon the internal combustion engine automobile, and EV will replace them and replace the world. With Tesla ambitious goals of achieving production of 1 terawatt-hour of battery in 2030 every year, Tesla needs to ramp up its production. For problem identification, the first question is, should we increase the production? As the demand of the EV increases, Tesla needs to expand to meet the increasing market and maintain its dominance and leading role. We will use quantitative analysis of forecasting here. For the second question, how to expand the production? In the short term, we will expand the production to meet the demand, but in the long term, we recommend to build an entire new gigafactory. For quantitative analysis, we'll here use aggregate planning and factor rating system. For the question 3 is how to maximize profit. The first one is maximize profit through selecting a new location for gigafactory. And the second one is maximize profit through facility layout. The quantitative analysis we use here is activity relation analysis, TCR summary table, and dimensionless block diagram.
For the methodology, in forecasting part, we use quantitative forecasting to predict the global EV demand as well as Tesla's Model 3 sales volume. To forecast sales of global EV, 3-year moving average, weighted moving average, and linear regression is selected. To forecast the demand of Tesla Model 3, 3-year moving average, weighted moving average, exponential smoothing, and linear regression is selected. The data representing demand for global EV and the sales of Model 3 from 2018 Q1 to 2021 Q2 are retrieved from statista.com.
For aggregate planning of methodology, this is a short-term one, and we will have the data from Q2 2021 to Q1 2022, and it will meet the rising demand. We will have the aggregate planning on two things. Firstly, the subcontracting of aggregate planning, and the second one is constant workforce with overtime. Third, but this will be short-term. For long-term one, we need to have a new gigafactory, and we will use factor rating system to determine a new plant location. We'll view different weighting for different factors. For example, we're waiting on supply, demand, and government policy.
In facility layout, we use systematic layout planning approach to determine the most effective physical arrangement inside the factory. First, data concerning activity will be sought out to complete the activity relationship analysis diagram in which AEIOUX will be assigned to represent relationship between factory departments. Then, TCL summary table and dimensionless block diagram will also be done. We used the Tesla factory in Fatima as an illustration in our case. By comparing the similarity of different researchers, we came up with 9 departments. So this is the quantitative analysis. So in the forecasting part, the sales of global EV would be forecast by the 3-year moving average, weighted moving average, and linear regression. And the forecast demand in 2020 is 330,000, 4048,000, and 4420,000 representatively. As a result, we can conclude that there is an increasing demand trend in global EV in 2012 to 2020. So For the forecasting of demand of Tesla Model 3, 3-month moving average, weighted moving average, exponential smoothing, and linear regression is selected. These are the forecasting data by 4 approaches. These are the ME, MAD, MAPE, and standard error of the estimation by 4 approaches. We can conclude that exponential smoothing works better as the smaller of MAD, MAPE the more accurate the resulting model.
For aggregate planning, this is the data we would use for aggregate planning. For the first one, subcontracting approach, we could see the demand is 165192 in 2021 Q2, and the demand in this four quarter was using linear regression method, because only linear regression method can produce more than one predictor forecasting demand. And we can see at the bottom, the full cost will be $13.764 billion in 1 year. The second one is constant workforce with overtime approach. We would see the demand is the same as the previous one, but the total full cost will be $13.712 billion. And we can see that the overtime approach with constant workforce will be about $600 million cheaper. So that we think that the overtime approach with constant workforce will work better for Tesla Gigafactory. But this is still a short-term one. But in the long run, it will still be very expensive and not efficient. For in the long run, we need to have a new plant, a new Gigafactory. So that here is the factor rating system. For example, the supply weighting will be 45, as we think that is very important, and the demand is less important with 25. So that we can see that the score of Shenzhen is 7,225, and the score of Tokyo is 6,850, and Shenzhen wins it. For comparison, for example, supply of Shenzhen is 75 max because it's great supply chain with previous experience of Shanghai Gigafactory. The demand is 70 max because it's the largest EV sales market in the world, and there is incentive to buy Tesla product. And the government policy with 25% of sales must be EV in 2025 and less control on Tesla operation. In Tokyo, Japan, the supply is 60 points because of Panasonic experience, but yet there's lack of natural resources. In the demand side, and this is the fastest growing EV market in the world. For government policy, this is 100%, it's in Tokyo, it requires 100% of EV sales in 2025, and there's a large incentive to subsidy EV production. So at the end, we conclude that Shenzhen, China would be a recommended place for choice of new Gigafactory plant location.
So for the facility layout, systematic layout plan will be carried on to determine the most efficient physical arrangement of production departments within the Gigafactory. An activity relationship diagrams is created to show the importance of relationship between any pairs of departments in the factory. So this is the total closeness rating is tabulated. After that, department orders are sorted regarding the priority of placing in the facility layout. So we can come up with the sequence as follows. Then, dimensionless block diagram, which aims to maximize the positive contact between departments, is made as follows. And this is the final layout.
For suggestion part, for forecasting, we find out that there's an underestimation of EV sales and Tesla Model 3 sales compared to the actual data. So that one of our suggestions is don't only look for the historical data. We found that because of the COVID-19 pandemic, and there is a stalemate of sales in the Q2 and Q3. And when it's Q4, it's bounced back a lot. So that we think that the suggestion is also focused on current data. For aggregate planning, we think that data collecting is very important because we do not have a lot of data. For example, if we have a lot of more data, we need to have more data, such as the fixed cost, the variable cost, variable overhead, and fixed manufacturing overhead, so that we could conduct different kind of aggregate planning approach. For the new plant location, the suggestion is to maybe add more factors. For example, adding factors such as pull and push factor from the government policy, which is pull factor is the government incentive for people to buy the EV, and the push factor is the the government subsidizing production of EV. Secondly, we think that it is choose a location, exact location for the analysis. For example, we can examine the infrastructure, such as the ports nearby or the highway nearby. For the facility layout, we think that the suggestion is to follow the optimized layout to increase the efficiency and maximum profit. And with more data, we can conduct a space relations diagram. For conclusion, for forecasting, the conclusion is exponential smoothing is the most accurate forecasting method. And refer to the first question, so that it's proved the rapid increase of EV and Model 3 sales, so that Tesla should expand their production. For aggregate planning, it showed that the short-term one is the constant workforce to rising the demand is better. But for the new plant location, Shenzhen, but for the long-term one, we need to have a new gigafactory. For the new plant location, factor rating system, different weighting on different factors, is that Shenzhen would be the better choice. In the facility layout, to maximize the profit, Tesla should follow the facility layout according to the dimension of the block diagram. It could increase the overall efficiency. This is the end of our presentation. Thank you.